Hello, this is Handbook 2, Exploring Data and Testing for Normality in R Commander. So once you've loaded your data in R Commander, you may wish to start to explore it. One of the first ways of doing this is to create a summaries of your data. The two datasets we're going to use in this example is called, the first is iris.csv and the second is trees.csv. Now both these datasets are available through the Science and the Environment Undergraduate Program's Moodle page, or in this case they're actually available within R itself. So let's start by going to Data, Data in Packages, and Read Dataset from Attached Package. The first dataset we're using is called Iris, so type Iris in here into the box, and then click OK. If everything has been inputted correctly, it should be blue down here, and just to check that your data is imported correctly, click on View Dataset. Okay, we've got 4 columns here with continuous data, so 4 variables, and we have a final grouping variable at the very end here with species naming. We can close that now. So first thing you might want to do is create a summary for each of those different variables. So you can do this by going to Statistics, Summaries, and click Active Dataset. You can see it's created a summary here in the output window for each of our different variables. So it's given us a mean, a first quartile, a median, a mean, third quartile, and maximum value. And it's done it for each of the 4 continuous variables. It's also told us here in the very last output how many observations for each species were counted. So we have 50 observations for each of these different species. What we may wish to do if we take it a little bit further is you may wish to see how one of these variables varies between species. And the easiest way to do that is to go to Statistics, Summaries, Numerical Summaries. It'll then prompt you to select a variable. We'll stick with the very first variable, so we'll go to petal length. And then it'll ask you to whether you want to summarize by group. If you've got any other grouping variable, you can use it here, but in this case we've just got species, so I can select that. It's already highlighted. Click OK. You can also add to the output. You can ask for a coefficient of variation, measure of skewness, and a measure of kurtosis. But we'll keep to the default for now, and we'll click OK. So again, looking at the output window here, we've got the mean, standard deviation, interquartile range, and sample sizes for each of our 3 species. So it enables us to compare the differences in petal length between these 3 different species. And you can apply this to any data set you've got. The next thing you may wish to do, one of the precursors of doing any statistical test is often to test for normality, because it's one of the assumptions of many of the tests that we apply. To do this, we're going to use another data set just to keep practicing entering different data sets in. If you go to Data, Data in Packages again, and Read Data from Attached Package. So remember, these are all up on the Moodle page as well, but this one's within our Commander itself, so we can go straight ahead. Type trees into here, click OK, and our data should be there. Okay, so it's come up blue at the bottom, which is always a good sign. Click on View Dataset, and we got 3 continuous variables there. We've got girth, height, and volume. So what we might want to do is to see how might wish to look at the distribution of the girth variable to see if it's normally distributed, whether it exhibits this bell-shaped curve or this bell-shaped distribution. Easiest way to do this is probably to graph it, to visually look at what our data look like. So if we go to Graphs, click on Histogram, and select girth, and then just select OK. Okay, so does it look bell-shaped? Not quite. It doesn't look a perfect bell-shaped curve, a bell-shaped distribution. So we may wish to test to see if our data is then significantly different from a normal distribution. And we can do this by applying a statistical test. So if we go to Statistics, go to Summaries, and then down to Shapiro-Wilkes Test of Normality. Again, we'll select the variable we're interested in, girth, and then select OK. What this test does is to test whether our data are significantly different from what you'd expect from a normal distribution. So the output we get here, we get a test statistic value, a Shapiro-Wilkes value, which is our W value here. We also get a p-value, and this tells us whether our data is significantly different or not from a normal distribution. So if it's below 0.05, it's significantly different. If it's above 0.05, it's not significantly different. So in this case, our data is not significantly different from a normal distribution. If we wanted to write this in a report format, we may write something similar to this. So you may say the tree girth does not differ significantly from a normal distribution. And then in brackets you'd put your W value, or your test statistic value, or Shapiro Wilks value, your N value, which is your sample size. So if we have a look at our data here, we've got a total number of observations we've got is 31, so our sample size is 31. And then finally we report the p-value. This is rounded up to 2 decimal places, and that's 0.09. And that's the sort of output that you'd write in a report. Where before we also produced a graph. If you wanted to go back and smarten up the graph to import into one of your reports, if you go to options, you can change some of the aspects of it. You can give it an XY label and a graph title. So in this case, I'm going to put girth as my X label, frequency or count on the Y label, and then I'm going to give it a title. So this is figure 1 and tree girth. And then click OK. And if we go back here, you can see our output in our output window here. Gives us our histogram again. So these are some of the things you do before you went into applying any statistical test. You may explore your data, create summaries, and you may check to see if your data are normally distributed or not. Thank you very much. Bye.